Okay, let's start this one. The topic is about the Docker containers today. When I was thinking about Dockers, I just wanted to give some context around it. In a particular context, I would like to give a use case and drive it rather than just talking about Docker. Then I thought that it might be a good idea to add a microservice use case to it and talk about it and then add value to the Dockers. There are so many ways we can use Docker as a container. In our use case, the whole agenda will be like this. I'm going to briefly discuss about the microservices a little bit, then jump onto the Docker, a little bit of basics, and what the structure looks like, and after that, a couple of use cases and where we had implemented the microservices and containers together for financial industry and healthcare, and how we succeeded, and all those things. I'm going to discuss about those things. About me, I go by middle name Naga. I work for Deloitte Consulting. I am from Application Architecture Community of Practice. And I have a colleague, Ansok Choi. He is based out of California. He could not join today, so I'm just running the show by myself today. I'm based out of Princeton, New Jersey. And we both belong to the same Application Architecture Community of Practice. And what is a microservice? Probably many of you know, and a lot of the people here are contributors to the Apache Foundation, and there is a very big, nice definition given by Martin Fowler, who is actually designed so many patterns and everything. And he says that it's an architectural style where you can break a bigger monolithic application into small pieces of service, small chunks of services, with its own capability to interact with the data sources and all, and they can be independently deployed and all. It means sometimes many people ask me, business people and other community people come and ask me, hey, what does it mean? One day I was talking to the business and they were not able to understand what does it mean. And then I made them a very, very simple use case for them to understand. Maybe it's good for talking to other business people also. You're going and ordering for a party a bunch of food. So they say that, okay, we serve in plates, and each plate will have an entry, starter, dessert, and everything. It comes as a set. You buy the whole set, and each set costs $10 or $12, whatever it is. So we order for 500 people, and some people eat rice, some people eat bread, some people eat something else. They leave something as it is, and it's a lot of waste is there. And when we ask the people to make 500 plates, it takes a lot of time for them to cook every item in the food required for the 500 people. Instead of that, I can go and add an order. I need only 500 desserts and appetizers, maybe 300, and maybe the main entry, maybe 200, something like that. The benefit of that is that if the appetizer gets out of stock or if it is burned, I can go and order quickly, hey, can you make another 200 or 100 appetizers for me? It becomes easy for them to produce. It's a very, very easy to explain. And I told them, just relate these to a microservice and mono, I told them. And each has got its own advantages and disadvantages, pros and cons, whatever you call it as. And in general, I put a lot of text there. This is normally kind of educational slide also for those people who wants to refer. But most of the things are, most of the characteristics, as Martin speaks, are it should have its own code base. It should have its own data, and it should be deployable independently, and it should be as modular as possible, and as minimum code it should have. There are so many things we can consider. And besides that, when it comes to the resources, because the amount of effort involved in these services, microservices, are much less, the ownership or the resources required for a particular service is also pretty less. So we can reduce the owner, and sometimes it can be a single owner too. And it can be technology agnostic. It's 50-50. Sometimes the benefit is that when you break into chunks, a particular piece you can build using Python, and a particular piece you can using Java, .NET, whatever it is. But most of the times we build using a particular technology stack. And easily replaceable, as it says, we can take a particular microservice and, excuse me. Sorry. So that particular service, if you wanted to make a change, if you wanted to upgrade either technologically or you wanted to add the business functionality, it would be easy for us to do those kinds of operations. Pretty standard. Then comes to the monolithics. We have been running these monolithics for a long time. It's like a big elephant. Sometimes these applications are pretty heavy. Still we have them. We will be having them too. There is nothing like that. You have to replace every monolithic with microservice or anything like that. It goes case by case. In some of the cases where we have seen that monolithics are doing better performance because of the interactions they have and all. So coming back to monolithic, as I said earlier, the example, the food example. So whenever you are making a big application, you have to deploy the whole application. You make a change that it involves all the SDLC steps. Somebody has to test it, and whether you need it or not, you need to make sure that the whole functionality has to be tested. And it takes time, resources, and it costs money, and the time to go to the market and everything. All these things come into a major play there. So those are all depicted in a different ways there. So these are the few drawbacks. So all these things, how these things came up over a period of time, everything is one is driving the other. The world has become very fast. Everybody wants information immediately. The business is fighting across each other's. Somebody comes into the business with a new feature, and others want to catch up. And how I can deliver faster than he delivers, or how can I get into the market before he gets into the market. All these things come into the play for all these evolutions. So the biggest advantage for microservices is that the business functionality is broken down, and a particular business functionality, a particular feature we have to enhance. You can take that particular microservice and build it and deploy it. So those are the things which we can draw. Those are the things which are difficult in monolithic. Sometimes all these services are grouped together as a big application, and it becomes difficult to deploy within time. That's one of the major drawbacks. So let's move on. And these are the benefits of the microservices. More or less we discussed in a different way. I do not want to go very deep into this one because we would like to jump onto the Docker and all. But at a high level, agility, resiliency, maintainability, scalability, performance, all these major architectural attributes we're going to cover here in this one. They're very important when it comes to the business services coming into the market, especially the agility part, which is very important. Now, these are the pretty standard features of the microservices. And one of the tools which we heavily use and which is open sourced is Spring Boot. And it is from the Spring framework. And it has actually built-in features, and it comes up with a starter framework where you can build a Spring Boot application with bare minimum structure, and you can add the business functionality as you go. And it comes with other tool suite like a Sleuth and circuit breaker pattern, which is implemented by Netflix, Headstricks and all. They're all pluggable. You can make them and make the service more robust and all. Okay, why we talked about these microservices and how they are connected to the Docker. Just I wanted to connect the dots here. As we discussed just now, microservices we wanted to deploy as a small service with certain minimum business capabilities with its own data set. That's fine, very good, nice. I have a service with data in it. That service can interact with its own data source, good. How do I deploy? You can deploy in multiple ways. You can build the same service and deploy onto the current WebLogic clusters, VAS clusters. What are the traditional servers you have? You can deploy onto them. Or you wanted to make it more modular and independent. The best way is to containerize them. Put them in a container, Docker container, and make its own way to float around, and that makes it not to stick to a specific platform again. Tomorrow you wanted to move out of WebSphere or WebLogic, any specific proprietary servers to open source. You have to make some changes sometimes in your applications and all to make sure that they fit for the corresponding application servers. So those things can be avoided. And what is a Docker container? Is a lightweight, standalone, executable package that has got all the necessary items to run it independently, and it can run on any platform. This is as per the docker.com definition. Code, runtime, system tools, system libraries, and all the things, even the configuration settings and all in one is a one package. That we call it as an image. You can run the image on any Docker compatible platforms. What are the benefits? The benefits are it's agile, and you can spin the containers quickly through DevOps models like continuous integration delivery. The same way you deploy an application to any application server, you can deploy a Docker image to Docker orchestration platforms like Docker Swarm, Kubernetes, or Mesos-based platforms like Mesosphere or anything. And you can do blue-green deployments. That are another benefit you get out of it. And you have one container spinning with the current version, and you wanted to deploy a new version. You can deploy it as a separate container and expose the APIs. Run it through your system, and once it is stable, you can retake the other system. So we always go with the blue-green deployments, and always have got you can port it across the machines, version control and component reuse sharing, lightweight footprint and minimal overhead, which is very important actually. Most of the containers which we use for microservices purposes, we try to limit them between 500 MB, sometimes 350 MB to 500 MB, 600 MB, 700 MB. We delivered that capability and all. And there are some services which are much higher size also. I was here talking to someone here. They have a huge service which is around 5 GB, he was mentioning. So there are some applications built and delivered. And one more important thing is Docker only for microservices? No, Docker can be used for monolithics also. We used containers for monolithics for a few clients in one of the applications. We built a microservice for them, breaking a current legacy application into multiple microservices. We have found other issues there. Then we moved there, we clubbed all the microservices within 3-4 days and make it as a monolithic, and we use the same Docker container and deployed them. So That is one beauty. Anytime you can make a multiple microservices monolithic and deploy into using the Docker containers. And they are secure. Many people think that security using the Docker is having some vulnerabilities and all, they are scared. But in fact, it is the other way. Using the Dockers, it's more secure because you have one more added layer on top of the OS. You have the host OS internally. I'm not going into the much more details of this, but definitely it is more secure. And you can see here the structure, the very bare minimum structure I put there. It's your infrastructure, and on top of it you have the host operating system, and then you can have the Dockers and multiple applications there. Yeah, a little bit more, go a little bit deeper into this one. You can notice here that we have the containers here and type 1, type 2 virtual machines. You can definitely see that the layers before reaching the application are or more or less in the case of Docker. Earlier cases we used to have, now Docker is coming up with, has already come up with the bare metal version, and which directly works on the host servers with OS kernel. Earlier they used to have the hypervisor and all. We have implemented also for one of the clients with the bare metal, and it's working perfect. And big advantage is that when we did the changes to the infrastructure level for Docker, we don't have to do any changes to the application layers. We just moved the images onto the new platform. We were doing, as I mentioned, like blue-green deployments. We were having the regular VMware hosted environment. We built a bare metal-based Docker infrastructure, and we deployed using the DevOps pipeline. Instead of deploying to the current infrastructure, we moved on to the other infrastructure, bring it up, and streamline that. Sorry. And there are a few much more details of the hypervisors for bare metal and all these things. And the concept of bare metal came because just as you all know, Docker actually an abstract of some of the Linux features into that. And the more the layers you have, the performance was getting a bottleneck. And in order to improve the performance and all, they actually thought of taking out the hypervisor in between. That was one of the reasons. And there are so many advantages. Is that solution perfect for everything? No. So it goes case by case, and Docker is the only solution for everything. Everybody has to move to the Docker? No. There are so many things into consideration, like what kind of application you are trying to do, what is the modularity you want to do, are you planning to move now or later from one environment to the other environment, do you have plans for moving currently from on-prem to cloud? So the biggest advantage of Docker is that you can build cloud-native computing related applications. Suppose you are building a microservice, a Java-based .NET, whatever it is, you bundle it or package it with a Docker image. Today you have it in the on-prem Docker environment. You can move the image onto the Amazon or AWS, or you can move it in the Azure, or you can move it into the GCP. Because as long as the underlying platform on operating system is Docker has it, or Docker binaries are there, you are good to go. So just this is a little bit old, but this is actually one of the statistics I just wanted to share with the people here. It's 2016. I tried to get the latest, but I was not able to get. This should have better figures, and the interest and the people who are looking for Dockerization are increasing year by year, and it's a very good sign. That's how especially with the cloud computing evolution, and a lot of people are moving more confidently nowadays, including, we have seen healthcare, finance, and even government sectors are all moving. I'm going to talk about the use case in a few minutes. And there are a few trade-offs, which actually I talked during the whole discussion here. Some of the things are, there are so many moving parts. The biggest challenge in the container world is that we started this at Deloitte around 4 years back. At the time, we were trying to find who are there for security, who are there for this, what are the platforms. Even at that time, Kubernetes was there, but it was having a lot of issues when we did the POCs, Mesos, Kubernetes, and Docker data center. Docker data center just came into the picture with the Docker Swarm and all. We did a thorough POC. We took about 2 months to do complete analysis, and we found the Docker data center with the Docker Swarm was much more effective, and it's good for use at that time. It's still good, it's still stable. They added Kubernetes functionalities and all. So where I'm connecting here is that there are a lot of moving parts in this. A lot of the ecosystem has come up pretty well, and day by day, the older things are getting stronger and newer things are coming and more efficient. So keep changing. The people have to keep up to date, and sometimes for organizations it's becoming very challenge to get approval of this ecosystem and move forward. That's one of the things. And there are sometimes expertise. We get a lot of skill gaps there. People are not well trying to utilize these, and that is leading to some kind of technical difficulties and performance issues and all. So that's one thing we need to consider seriously. As I mentioned here, there is a point here. Containers can be deployed using bare metal, and still the vulnerabilities, whatever the kernel has, the parent has got, it will be carried over. And we keep on updating these vulnerabilities and matching them and tuning our images and our security and all to that part. Sorry. So there, yes. Yeah, nice. There are a lot and all, so there's a big laundry list. I just would like to move on. And we have good success stories, and there are struggles behind that. I just would like to share a few of them, which might be very useful. So this is one of the, we built a digital banking platform for a commercial banking industry. The challenges they have is that they have a lot of problems in handling globally P2P, the payments, mobile payments and everything. They were planning to do how they have big third-party purchased softwares and engines and whatnot. They're paying heavy price for all those things. They wanted to replace by building in-house services, and they wanted to make it faster, interoperable, and all these things. So what we did is that we analyzed the whole system and then broken down the business requirements into the various microservices, and we built microservices for them. And through the API gateways, we exposed all the services through APIs, and we gave them the product available, and completely APIs based, and it is being used not only in US, it's being used worldwide. They have offices in Africa, Europe, and Asia, so many places. So we did pilot for only payments. Now they are doing it for all other banking divisions like commercial and everything. Okay. The other thing they are doing is investment banking now. And this is for a health plans provider, an insurance industry, where they wanted to move the legacy claims modernization. The whole claims system is in mainframe. The earlier things were products from vendor products. They don't know something black box. Now here, the other challenge is they have the in-house COBOL programs written on mainframe. And the biggest challenge is that there is no good documentation. There is a big difference between the code in production and what the documentation says. So it's a it's a common problem everyone faces, and what we have to do is that we have to. People were not. The biggest problem here is that whenever we speak all these open source products and Docker, and these are very good, and we are all here working on these products, and we love them, and we are very confident to bring them onto the table. But on the other side, the people who wants to use, they always have a lot of questions. Does this work? Did it work anywhere? And all kinds of questions we face. And most of the clients we face, they have more or less the same questions. So what we have done is that we built some patterns, and we build some prototypes, and we go them and we show them the performance. Hey, this is your program. Because it's very difficult to hit the performance of an application written in assembly language or COBOL programs on mainframes. Mainframes are very powerful machines. So if you build an application, a microservice with its own data source, and you're Dockerizing it, there are layers and service-to-service calls, latencies, all these included, external calls to outside parties like Bing, maybe Google Maps to get some of the geographic locations. Those are all becoming challenges, especially in the clients. Sorry, it's getting timed out. Yep. So what we did is that, what the approach we did is that go read the code, make the documentation, and then build, identify which parts of the service you can break down into microservices and Dockerize them and push them and test them. So there are two tracks that were running together. The legacy is keep running and build the services slowly. And once the particular functionality has been built, then it is streamlined, because they're all through APIs and RESTful APIs or through API gateways and all. They're making calls, and they were changing. So this is a very big challenging project, and we were successful. We implemented all the open source technologies here, Spring Boot and Apache, a lot of NiFi and a lot of stuff there, besides just Dockerizing microservices. And Spring Batch we used as Docker containers. And we used some of the UI functionalities. We use Sencha, which is a proprietary. They don't have Docker, they were charging. So we made it Dockerizable. Angular JS. Many people have done it, but I'm just giving an example. The client was, sometimes it's very difficult to convince the client. So finally we were able to do that. And another healthcare, this is a different use case. They have all the microservices written partially. They are all having monolithic services, Java-based services running on WebLogic and WebSphere platforms. Both they have. Some are running on Tomcat too. And they wanted to convert them into microservices and Dockerize them. They have the plans in mind, but not sure of the strategy, how to do that and all. People like us go there and talk to them. Hey, why didn't you use this? Why didn't you use that? Then the Docker came into picture, microservices came into picture, and they were not confident. And we had to take them all the steps like the other people and build the services for them. Moved all the SOAP-based web services as RESTful services, first in a phased way. We have broken them into monolithic into microservices and pushed them onto the same WebSphere WebLogic servers. We didn't still Dockerize them. They should get the confidence. Okay, let's break the mono into micro. Then deploy the micro onto the same platforms they have. We took around 50 services. We asked them the criticality levels, low, medium, high. So a couple of very high, very critical applications, few low, medium, and many of them are low priority or low critical items. We took them and then converted them into micro and pushed them back onto the same servers. We didn't put them onto the Docker yet. We went by phased manner, sorry. And then take the microservice that is stable and put them into the Docker containers and push them onto the Docker data center. And that also we took in different phases in a planned way, and finally we were successful. Right now, when we did the pilot, we just picked up 50 services. Right now, after we handed over them all the documentation, how to do on this, they have moved around 1,500 services onto the Docker platform. Yep, I take a pause here. How much time? Yep, for any questions and answers or anything. Yep, sir.
Do you feel like, so I use Docker a lot to make my development life easier. Is there anything I should be nervous about? Like, is there anything that you end up doing that optimizes for the developer experience and makes it harder to deploy?
Yeah,
Any thoughts on?
Yeah, that's a very good question. We did some accelerators there. The question is there a way we can help the developers to accelerate their kickoff when a new resource joins? Or am I correct? Yep. How can we accelerate it? What we did was, that's why I like that. We made virtual boxes as a development environments, and we deployed them using Vagrant boxes and all. Now any developer they have two options. Either they can straight away use the virtual box as it is, or if they don't want, we have the options to deploy using the Vagrant to them. Yep. Both onto the virtual. If they have VDAS environment, we can deploy to there. Otherwise, if it is local, we told them, okay, download this from the local secure share file or anything like that. That's a very good point. What happened is that in one of the use cases, the client wants only a specific version of the JDK. They want JDK 1.7. For some reason, they are sticking to JDK 1.7. And the entire organization, other services are on 1.8 and everything, some of the applications. And they want the developers to use only 1.7. So in those cases, we built these boxes for them. And they were very useful because there are certain suite of applications that work with 1.7. Suppose you take the case of NiFi. And now it works only 1.8 and above. The latest version, basically. So similarly, there are so many applications that do not work with old versions. So we used Vagrant and virtual boxes for that. So I built different virtual boxes. Even there, after that, I built around 4 or 5 virtual boxes with different Java versions and different application suites that come with that. And I shared with all the people, anytime you want this particular Java version ecosystem, use this virtual box. Yep. Is that covers you? Yeah, thank you. That's a very good question. Yeah. Yes, sir.
What approach would you take when identifying monolithic applications to containerize? How would you go about identifying the process to do?
Yeah, the question here is that how do you identify a monolithic to convert into a microservice? Yeah.
What process would you take to identify those microservices that would be develop microservices?
Yeah, what is the process we follow and all? That's the following question is. The best thing is to sit with the main, the business people and all. Identify the business goals, their vision, and what are the objectives. Based on those priorities, we need to identify the applications that are high priority in terms of cost. Some of the products or vendor products, they may be costing them 9 million or 10 million. By bringing them into the in-house, they can save a lot of money. So it is there in their agenda. That is a very good opportunity for us to pick up that. And then when you are converting them, convert the mono into micro. That's one of the analysis points we have to consider. And second thing is that they have very painful application. These are all we need to we need to interview the people who are asking this. We need to go and sit with them, talk to the business, talk to the technical teams, architects, all these stakeholders should be there to answer all the questions. So one of the points is what are their most money, OPEX, in one word we can say OPEX. The other one was CapEx, and this is OPEX, where you are burning a lot of money per year in terms of human resources, maintenance, software, hardware, and all these things. So that is one of the factors. We need to analyze that. If you are spending, you need to plan for a 5-year ROI, and a thumb rule, 20% we get back in a year. So if you are making a major change, you are burning 9 million now, and by converting that to the new application, microservice, after 5 years, how much money you save, are you going to get back in 5 years, 20%? These are the general math we need to do around that. There are so many, but these are the few important things we need to consider. And what technology stacks they have, what is the strategy, are they going to be on-prem or cloud, which cloud they take, how much it costs there, are they moving the data there, are they moving the data here, because the data transfer costs a lot of money. So these are all the factors we need to consider. Yeah, yes, sir.
You mentioned that using microservices inside a container allows you to switch out the platform, right? So that you can have a microservice architecture-based API gateway. And I'm assuming it's running inside a Spring Boot, which is what, Tomcat?
Yeah, you can, yeah, it can be Tomcat. Yeah.
So it's going to be WebSphere or WebLogic as well? Or?
Yeah, that's a very good question. There are Spring Boot by default comes with a few servers like Jetty, Tomcat, Undertow, and all. We did POC with WebSphere, Liberty, and WebLogic. They all came with miniature versions of the application servers nowadays. But still, when we tested with the application servers around 2 years back, because I didn't test it recently, I need to do one more test. We found the Undertow from JBoss was having the good performance. It was very good for non-blocking IOs and all. So that answering your question, yes. But out of all these things, we found Undertow was better. I need to recheck one more time, because over the period of time, over the past 2 years, all these people have come up with the miniature versions, and we need to see how they are performing. One more assessment we have to do. Yep.
All good?
Yeah, I think so. Yeah. Thanks, everyone. A lot of good questions. Thank you so much.